use the squeeze theorem to find the limit of f of x as x approaches 0. And f of x is equal to 3 plus x times the cosine of 1 divided by x. So the first thing that we need to do is we need to break our function f of x down to its parent function, which in our case is going to be the cosine of 1 over x. So we know that the cosine of 1 over x oscillates between -1 and +1. And now we're going to manipulate this compound inequality until we get to our function f of x that we have there. And then we're going to evaluate both the left and right sides of our compound inequality. All right, so we know that cosine of 1 over x falls between -1 and 1. Next, we have to multiply all three sections by x. So we have an x that would go in front of that, x times -1 and x times +1. So we would have -x is less than or equal to x times the cosine of 1 over x, which is less than or equal to x. And now we have a 3 added to this out in front. So if we add 3, and add 3 in the middle, we will get 3 minus x is less than or equal to 3 plus x times the cosine of 1 over x, which is less than or equal to 3 plus x. And now we can use the squeeze theorem with the left and right sides of our compound inequalities to determine this limit. So if we do the limit of f of x as x approaches 0 from the left, we are going to have the limit of 3 minus x as x approaches 0, which is going to be 3 minus 0, which is equal to 3. And then if we find the limit of our function f of x as x is approaching 0 from the right, that's the same as taking the limit of 3 plus x as x approaches 0 from the right, which is equal to 3 plus 0, which is equal to 3. And earlier when I did the substitution or writing the limit expression, I needed to put parentheses around this so that we can use direct substitution in the entire thing. So notice we have both 3 when evaluating it from both the left and the right. So by the squeeze theorem, the limit of f of x as x approaches 0 is equal to 3. Answer choice D.